suppose I tell you I'm throwing a ball by 20 meters per second and I only give it a horizontal direction, and then the ball falls down. Here's, let's say, a table or whatever, something like that, and the ball lands on the floor within 60 meters from the leg of the floor. I'm wondering how high the table is and how long did it take the ball to hit the floor to get here. Okay? Remember, it's a path, it's a curvy path. However, we split it into X and Y directions. Along the X, it holds the constant velocity. Along the Y direction, though, it's a free-falling motion. It's accelerating. Free-falling is an accelerating motion with acceleration of 10 meters per second squared. Okay? So let's just rewrite things. X components separate from Y components. So Vx is 20 meters per second, and I know it's going to be constant for the whole motion. I also know where it hits the ground. It's actually, see, this is horizontal. This is also horizontal. So they go together 60 meters. Now I'm wondering what the time for the time of flight is, and then also I was wondering for the Y direction, I was wondering about the height of the table. Okay? So let's just begin. Along the X direction, I go with a constant velocity of 20 meters per second. So this 20 meters per second, and then I'm looking for the time, and I also have already the X, the distance that where it lands on the floor, and it's exactly horizontal as well. So horizontals go together. I already know V is distance over time. I already know my my velocity. I already know my distance. See, all of the X's go together, and I'm actually wondering how long will it take? Therefore, time equals 3 seconds. So it takes the ball 3 seconds to get off of the table and hits the floor, and it actually lands 60 meters away from the leg of the floor. Okay? I want everyone to understand that this time is a common factor for both X and Y directions. Why? So this T, I tell you why in a second. T is the common factor for both X and Y directions. Right? Why is that so? Because it's one time that it hit, it's just one ball with one time. So although I split the motion in X and Y directions, it was still one ball. It was my mathematical trick that I treated in X and Y directions, although it was one time, right? So it's just one ball, and we only have one time that it just is at X and is at Y. So Y here is vertical, which I know I have acceleration for it. And if I'm wondering about this, Vy is Y over T here, where my T is now 3 seconds. But what is Y here? Velocity. Velocity is changing all the time. And since the first we don't have any velocity along the Y, it was only 20 along the X, we have initial velocity along the Y for 0. And because we figured out it's got 3 seconds to get here, after 3 seconds, 0, 10, 20, 30, our final velocity when the ball hits the ground is 30 meters per second. If I know the velocity is changing all the time, I gotta be having an average velocity right there. Average velocity is 0 plus 30 over 2, which gives me 15 meters per second. Why 2? Because it's 2 velocities. Average is numbers divided by the number of numbers. 1, 2, divide by 2, 15. So I put 15 there. So 15 equals y over 3 seconds. Y is 45 meters high. Okay? So this is an overview of the whole thing. I'll talk about the rest in the next video. Bye-bye.